Okay, we're going to look at FRQ1, mock FRQ1, part D of the function analysis. Now, just keep in mind that all of these questions will not be on one single FRQ. This is kind of an FRQ on steroids, but it covers a whole bunch of topics and a whole bunch of good calculus, and hopefully we'll review a lot of things for you. Okay, let's read the question, part D. Let y equal h of x be a function such that dy dx, the derivative of y with respect to x, is equal to f prime of 2x. Now remember, f prime is the graph that you have, we're given, times the quantity 3y minus 1, where y is greater than 1/3. We'll see where that comes in later. Find the second derivative, and then use this expression to determine if the graph of h of x is concave up or concave down at h of 1 equals 2. So remember, h of 1 equals 2 is an ordered pair. Wants to know what the derivative is at that ordered pair. Remember, second derivative is positive if it's concave up and negative if it's concave down. So I already wrote down my first derivative here, so I can use product rule to find my second derivative, right? We have a product here. Okay, so second derivative is the first times the derivative of the second, and now we're finding the derivative of y with respect to x, so this part is implicit. So it's 3 dy dx plus the second times the derivative of the first. Well, the derivative of the derivative is f double prime of that argument times the derivative of the argument, chain rule. Okay, so there is your derivative. You'll get a point for being able to find that correctly, but now we need to evaluate that derivative at the ordered pair given. So the second derivative at 1, 2. So let's plug in 1 for x and 2 for y. So f prime of 2 times 1 times 3 dy dx at 1, 2. So I'm going to have to go back to my first derivative to figure out that number. Plus 3 times 2 minus 1 times f double prime of 2 times 1 times 2. Okay, so let's work through this. F prime at 2. 2 times 1 is 2. Well, f prime is the graph of the function that you have. And when x is 2, what is the y value? Well, you have an ordered pair up here. So it's 5. So f prime of 2 is 5. Times, I need 3 times my first derivative at this point. So let's plug that in. 3 times f prime of 2 times 3 times 2 minus 1. We'll come back to that afterwards and get that number. Plus, here I'm going to have 6 minus 1 is 5 times f double prime at 2 times 2. Alright, let's see what we have now. So this is going to be 5 times 3. F prime of 2, again, I'm going to use that number again, is 5. So that's 5 times 6 minus 1 is 5, so another 5. Plus 5 times, well, what's f double prime at 2? Well, the second derivative of the first derivative is going to be anywhere you have horizontal tangents. So if I look at my graph, at x equals 2, I have a horizontal tangent, so that is 0. F double prime of 2 is 0 times 2. So this whole term turns 0, that's 0. So what do we have here? 15 times 25, which is 375. Well, that number is greater than 0. Therefore, at the ordered pair 1, 2, what is that function called? H of x is concave up, because you're second derivative was positive. Okay, that was part D. Okay, let's look at part E now. Consider the function y equals h of x from the previous part D. For values of x that are in between -1 and 5, on what intervals is f of, or h of x increasing? Give a reason for your answer. So how do we know a function is increasing? That's when we take the first derivative. Function is, and then we find the critical values. So they gave you the derivative of h in part D. So we want to know when is f prime of 2x times 3y minus 1 equal to 0. Well, that means you're going to take each factor and set that equal to 0. So f prime of 2x has to be 0, and then 3y minus 1 has to be 0. So this is the easy one. Solve for y. Y is 1/3. And in part D, they told you that y is greater than 1/3. Therefore, we know that your first derivative is greater than 1/3. So that's part of your answer. Your function is increasing when y is greater than 1/3. Okay, let's look at the other part. F prime of 2x equal to 0. Well, we know that we want f prime of 2x to be greater than 0 in order to be increasing. So you want to go back and look at your graph. So here's the graph. According to the sign chart that we made earlier, this function is increasing between 0 and 4 because the graph of the derivative is above the x-axis, and it's also increasing between 6 and 10 because that part of the graph is above the x-axis. So that tells us that we want to know when is 2x in between 6 and 10, because that's where your derivative is above the x-axis between 6 and 10, and then it's also above the x-axis between, as I say, 0 and 4. So now you have two inequalities, compound inequalities. Just solve that, and we can find the interval that h of x is increasing. So solving this, I'm going to divide all three sections here by 2. So 3 less than or equal to x less than or equal to 5. And then over here, 0 less than, we'll divide everything by 2. X less than or equal to 2. So there's the 4 values when h of x is increasing. When y is greater than 1/3, when x is in between 3 and 5, and when x is in between 0 and 2. Okay, now let's look at part F. Part F is a differential equation, which is, again, a very abstract kind of question, but it's covering another topic. So consider the differential equation from part D, and it's differentiable because of the way it was written. dy dx equals something in terms of x and something in terms of y. Use separation of variables to find a general solution for y equals h of x of the form ln absolute value 3y minus 1 equals a times the function in terms of bx plus c, which looks very abstract, but you know what? Just go through the motions of solving that differential equation. So the first thing that you want to do is separate your variables. So that means I'm going to bring the term of y in it on this side, and then I'm going to put the dx on the other side, so f prime of 2x dx. So there's your separation of variables, one of the most important steps of solving a differential equation. All right, now I'm going to integrate. So this is actually a u substitution. U is 3y minus 1. Du is
the absolute value of 3y minus 1. Okay, so we already have part of what they're asking us to find, but we'll have to get rid of that 1/3 maybe. Equals. Now when we integrate f prime of x at some inside, we're going to get f of x. But this is also a u substitution. U is 2x, du is 2 dx, or 1/2 du equals dx. So when we integrate that, we're going to get 1/2 your function f of x at the inside plus a c. So are we in the form of what they were asking for? Not quite. We don't want a coefficient next to, we don't have a coefficient here, so we want to multiply both sides by 3. So ln of the absolute value of 3 minus y equals 3 halves f of 2x plus 3 times the constant, but that just becomes another constant. So there we go. So this is an excellent example where you're forced to think about lots of different topics in calculus: concavity, increasing, decreasing, first derivative, second derivative, analysis of a graph, finding maxes and mins, absolute max and mins, solving differential equations. Hits on a whole bunch of topics. So I would go through this again, make sure you understand all the parts. If there's anything that you don't understand, send me a message